Yo, how are we going? Let's get into it. How's everyone going? We've got some regulars in chat. It's a little bit quiet today. Not as many people today. Right, it's Tuesday. People are maybe staying up late in the holidays. It's 11 o'clock. Day 6 of ISO. How's everyone doing today? Oh, Kate getting hit with some ads. What? No way. We got Hannah here. We got Vash. Felix and Ukulele are here. Rebecca's here. Who else is hiding in there? Oh, it's starting to pick up. Tina's here. We've got the usual crew. A lot of the girls are making sure they're here. A lot of the boys are getting slack, staying up late playing games. Today's an important lesson. It's going to be a little bit tricky. We're not going to necessarily learn anything new, but we're going to apply what we've learned over the last day or so to some harder looking questions. And I've grabbed 3 past paper questions that we'll have a look at that are literally taken from 2016, 17 and 18. Right, but firstly, yesterday I left you guys with this question here. If I was in class, hands up if you've done it. Hands up if you did your homework. Don't lie to me. Right, but let me know if you did your homework. Let me know if you got an answer, and I'll get through this really quickly. Right. Oh, I'm talking about tired. I just got suddenly very tired. My little study room is so warm. It's like that temperature that makes you sleepy, you know. I also forgot to charge my iPad last night. Right, we're off to a rocky start, but let's get into it. Just a heads up, I've done so much damn work for this session, right? Just a quick preview. That's all the work I've done this morning. Right, I woke up at 8 o'clock and did all of that this morning. Plus, I did some late last night. Plus, Mr. Miraji did some last night too. So there's 2 teachers, several hours gone into this one session. Okay, so very grateful that you guys are here. But if we can spread the word too and make sure everyone can get here, that'd be good. Okay. Hannah tried, was struggling a bit. Kate's done it. Let's look at this question. It's a little warm up. Right, let's warm up with this question. Have a look at it, and see how we go. Okay. So the first thing when we see this question, Daishok says here, good, better late than never. The first thing we got to do when we see this question, I'm going to write it out over here so that my room turns out all right, like this. Hey, Mr. Miraji, I sent you a message early on about the mistake. What am I right? Am I right? And is that mistake true, or have I done something wrong? Yeah. Okay. Cool. Right. It's not a big mistake, right? It's not a big deal at all. But I just thought I would catch it. Right. Let's look at this question. Z to 3 equals minus 1 minus root 3i. We have to change this into r cis theta. That should be our first go-to. For r, we know that it's going to be the square root of 1 squared plus root 3 squared. So far so good. And that's quite clearly going to be the root of 4, which is 2. Easy peasy. And then our angle for theta, we could draw a quick diagram. We know that it's going to be minus 1 and minus some imaginary number, so it's going to be something that looks like this, which means our tan inverse is the opposite, which is root 3. Oh, my camera's just died, hasn't it? Oh yeah, you hear the noise? I don't know why it does this. I need to troubleshoot it, but I can't be bothered. Give me a second. There we go. Right, we got this. We did this. We've done the inverse tan of root 3 before. I was about to do it on my real calculator, but I'll do it on the one on screen. Inverse tan of root 3. Oh, I want to go to degrees because I know it turns into a nice degrees. 60 degrees. Now note that angle is this angle here is 60. Therefore theta, which is this part, is going to be 180 minus 60, which is 120. Okay, I'm just going to open a window. Hopefully my flatmates don't mind because it's really hot. Okay, so far so good. So I'm going to rewrite my z to the 3 as my r cis theta, which is 2 cis, and my theta is, oh, what did I miss about my 120? Silly boy. Minus 120, like that. Almost lost that. Yeah, you guys just spotted it just as I spotted it too. Right. Isn't negative minus 120. Boom. 3 of you are on point. Honestly, today I've been doing these questions and I've just been making silly mistakes the whole time. So please be attentive because I'm going to make some mistakes. I just, one of those mornings, you know. Right, we've got this. That's good so far. And then we can also say that this could be minus 120 plus any infinite number of circles, of loops. Right? So if this is the case, then we apply de Moivre's theorem to, I'll do this one the long way, but the rest I'm going to take a lot more shortcuts. Oopsies. Because I don't want to have to write this out every time. This is all to a third, which means we get the third root of 2, which I'm just going to write as the third root of 2, cis, and we've got minus 120 divided by 3 is minus 40, and 360 divided by 3 is going to be 120. We happy? So far so good. And we're going to do our values of n. Now because we know z is 3, so z is to the power of 3, let me show you up here. We see the z to the 3, or the z to the 3. We know that we're going to have 3 solutions, and we always know it like pivots around 0. So we're going to start with n equals minus 1, and then n equals 0, then n equals 1. Those are our 3 values. Okay. If n was minus 1, we'll get a z of third root of 2 cis minus 40 minus 120. Minus 40 minus 120 should be 160. And then we got if n equals 0, then z would equal third root of 2 cis minus 40. And if n equals 1, z would equal third root of 2 cis minus 40 plus 120. 80. And we're done. Any questions on that? We've got to be able to do this to advance any further. We've got to be able to do this if we want to go any further with these sort of questions. No ugly conversions because I used my brain, Hamza. I used my big brain, which Fat Pikachu can see. I used my big brain to decide I start with minus 1, 0, and 1. Because z to the 3 is always going to be minus 1, 0, and 1 for my n values. Can I quickly go through question 4 from yesterday? I can give you the answer. I might have it somewhere. I don't even know where it is. Which one is it? Nah, this is the same thing. It's almost identical. Do you want the answer, Hannah? It's almost identical as what we just did, just with a different end value. Maybe if we get time, we'll do it at the end. Otherwise, I'll just post my answer and you can have a look. Because today's a big lesson. We've got a lot to do. Oh, you're doing a different question 4. We're doing this question 4. If you're doing this question 4, that's a bit of a beast. Right? Let's... not that one. Okay. Right, let's have a look at this. Now, I'm going to kind of do this same sort of style question, but we're going to look at some of these interesting cases that you can see over here. Right? So let's look at example 1, where we've got z to the 3 equals 8. Now this looks reasonably similar to this question, except it almost looks easier, right? Where we've got, instead of z to the 3 as some complex number, we've got z to the 3 is definitely equal to not a complex number, just a real number, 8. But let's do everything exactly the same as we just did, and sort of see what happens, right? Because every number is technically like a complex number, it's just got an imaginary part of 0. Right? So you could say that this z to the 3 is equal to 8 plus 0i. So let's treat it like this and carry on. Yeah, Kate's exactly right, your I is 0. So z to the 3 equals 8. We have to change this to r cis theta, right? Where in this case, our r is equal to the square root of 8 squared plus 0 squared, which is just going to be 8. And our theta, we don't even need to do a calculation, we can probably think with our brain that the number 8 is just going to have an angle of 0. So theta equals 0. So you could almost do this conversion very quickly if you knew that this was 8 cis 0. And every real number will be like that. Or it'll be the negative, let's say it was negative 8, it would be negative 8 cis 180. Okay? So let's have a look. Now, Daishokusai's right. He's just said that z equals 2. Right? He's right, but he's not fully right. Because the fundamental theory of algebra says that there must be 3 answers to this. Right? There must be. Z to the 3, there must be 3 answers. And I know that 2 to the power of 3 is 8, right? We can test that. I know this is true. So I know the answer is 2. And if you're in year 9 or 10, that's the end of your brain. That's it. But we've got big brains here. We know the fundamental theory of algebra tells us that we're having 3 answers. So if one of them is 2, the other 2 must be somewhere in the complex realm. Right? So, oh, I dropped my pen. So let's have a look at this. Let's carry on as if it was just a normal question. Right? So from here we normally go z to the 3 equals 8 cis 0 plus 360n. If I keep looping, I'll still land at exactly 8. Right? That means z equals, I'm going to do the 8th root, the 3rd root of 8. You can do it like this if you really wanted. So this front number becomes 2, and I divide everything in here by 3. 120n. That's de Moivre's theorem. And that must mean we're going to start with n of minus 1 because we've got z to the 3. I'm doing a lot of steps at once here. Hopefully you're still with me. Z equals 2 cis minus 120. Oopsies. Don't go too fast. Z equals 2 cis 0. Z equals 2 cis 120. Happy with that? Let me know if you're happy or not. Right? And our answer of 2, which was our original disulfide's original answer, right, is this piece. You can see that. And in fact, what I'd like you to do is to draw this, okay? So, like I haven't reminded you guys in a while, but please, 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 have a book out in front of you. Yes, of course you need the 3 roots, right? Of course you need 3 roots, because you are in calculus now. You know that the fundamental theory of algebra states that there's 3 answers. So you can't just leave it as 2, because that's not fully. And the question might even ask, like, find all the possible solutions of z to the 3 equaling 8 or whatever. But now I want to plot this on a diagram. Kate, you think that's cool? Let's look at this, right? Now, if I plot one of these, obviously this one is going to be the middle one. This one here is just going to be this, like that, right? Let's draw that. Now, if I move minus 120, I'll end up sort of out here. Not quite like that angle. 90 plus 45, 135, right? So it's like here-ish. This is minus 120. And here-ish, which is positive 120. And it's quite a nice aesthetic drawing, right? Because it's kind of symmetrical in the top and the bottom. You with me so far? All I've done is just drawn the 3 solutions, right? Just to look for patterns. But we've now found, I can tell he's being sarcastic. We can now we now know that there's actually 3 numbers that make this thing true. The whole point, and this is where I had this epiphany, where the whole point of what we're doing, these 3 answers are, if I took this to the power of 3, I would get 8. If I took this to the power of 3, I would get 8. And if I took this to the power of 3, I would get 8. That's literally what this whole thing has been about for the last 2 days. We are finding numbers that when you power them to the power that is in the question, you get the answer. Okay? Epiphany is not a big word. Let's look at example 2. Okay, these are sort of interesting cases that will better prepare us for harder questions. So example 2, we've got z to the 4 equals 16. Now if you took the 4th root of 16 on your calculator, 4th root, oopsies, of 16, you know it's 2. But we can also kind of have a look at this, right? Because we know there must be 4 answers. Do you reckon you could tell me one of the other answers straight away? I might even take this a different route to what I was thinking, right? Yeah, I want to let you guys try this, but I want to say you could do this a little bit more cleverly. We know z must be 2. There's at least one other answer that you could tell me straight away. Isn't there? Yeah, z is minus 2, right? We can double check it. That's going to work too, right? Agree with everyone above? And if we plotted this, I already know that one of our answers will be like this. 2 and minus 2. If we use a bit of logic, we could probably figure out the other two, but we could also do it using the theorem we've just learned, right? I want you to think logically whilst I do it the long way, right? Think logically and tell me a guess at what you think the other answers might be, whilst I do it the long way, okay? Remember, we know that these other two answers basically have to be complex in some form or another, because there's no other one. 1 and minus 1 is definitely not going to work, right? 1 to the power of 4 is 1. We've got some really interesting answers in the chat. This is good. You guys are thinking, right? We've got 2i and minus 2i from Hannah, and we've got 90 degrees and minus 90 degrees from Tina. Both of which I kind of agree with, right? Let's go through it the long way, and you'll see why I agree with both of you, because you're both right, but you're kind of just saying it in different ways. So we know that z to the 4, if we turn it into r cis theta, is just going to be 16 cis 0, which is the same thing as 16 cis 360n, which if we take the fourth root of everything, or if we do de Moivre's theorem, this becomes 90n, right? Let's start with n of 1, sorry, n of 0, 2 cis 0. That's this first answer here, right? Let's take an n of 1, 2 cis 90. Well, where's that going to be? 2 cis 90 is here. Oh, no, it's not. 2 cis 90 is here. 2i. And you can already see the pattern, can't you? 2 cis 180, isn't it? Which is the next one. And the last one you could say, I'm going to use minus 1, but you could say 3 and convert it to cis minus 90. And you can kind of see this pattern happening, right? It's interesting. It's good to think about. It's not super important, but it's if you're able to make these connections, which you guys have, it better sets you up to just kind of understand this at a deeper level. Everything is symmetrical, and it's all separated by the same sort of thing. We create a circle. Yes. Right. Let's look at this last case, where it's slightly different. And so see, now I'm having such a weird day because these two notes. You know how I said I was doing these problems this morning? I did both these problems this morning, and in both of those two problems, I made a silly mistake. So I don't even trust my notes anymore. So let's have a look. Maybe this one's wrong too. I think it's right. Whew. So let's have a look at this one. Z4 plus 9i equals 0. So Z4. Firstly, before I even look at this, remember I always say this in maths, right? What's the problem? Right? I'm already so like on board of making you guys do it. Yeah, I'll fall asleep if I just sit here. Right? Right. Tina's on the money, right? One of the problems with this question is it doesn't quite look like how we've seen them before. And so we need to rearrange. Right? You've told me what to do. I'll happily do it. Minus 9i. And then the next step is going to be what? Again, think about it. What's the problem? Well, we can't do anything until it's in polar form. So that's our next step, and you carry on like that. That's like the assignment questions. Oh, who would have thought that if you tuned in, I would give you questions similar to the assignment and the assessment? Big brain. Big brain. Okay, let's do this one. You should be or almost finished, to be honest. So I'm going to turn this into r cis theta. So r is going to be the square root of 0 squared plus 9 squared, which is just going to be 9. And theta, we got minus 9i. There's no other part, so we know it's going to be minus 90. No calculations needed, just an understanding of the diagram. So z to the 4 equals 9 cis minus 90. And then z to the 4 equals 9 cis minus 90. You could say this is true. De Moivre's theorem, this bad boy. 4 root 9 cis. We're getting significantly faster at doing this, right? Yesterday this took like 15 steps. Now, I don't know how to do simple maths. Minus 22.5 and 360 divided by 4, which is 90. Let's start with n equals 0, because I always like starting with that. 4 root 9 cis minus 22.5. N equals 1. Focus, team, focus. Or maybe you already finished this question. 4 root 9 cis minus 22.5 plus 90. 67.5. Can I do an n equals 2? If I add another 90 on that, that'll be fine, won't it? That's what I think. Plus another 90. 157. And the last one must be a minus 1. 4 root 9 cis minus 22.5 minus 90 minus 112.5. Like that. Okay. Those are our 4 answers. And if you plot it, which I'd like you to do, please. If you plot it all on a diagram, you'll see it's not quite as nice as the other ones we looked at. But think about this, right? 22.5, that first one, is half of 45 degrees, right? So that's going to be like minus 22.5. It's going to be like this. No, not like that. It's going to be half like that. Sort of like this. That is the first one. And each rotation, or each root, is a 90-degree rotation of that. Now that diagram is not perfect, but if you think about it, that's like a square angle there, and there. Maybe that red didn't help. But each one of those is the 90-degree rotation. Which again is quite an interesting picture. And it's kind of good to know. Right, so far so good. No questions. Feeling okay? Hums is happy. Right, don't worry about trig. Trig is another easy as internal. Okay, but it's also, we basically teach trig because it's in your differentiation and integration paper. Right, and it's not just SOHCAHTOA. If you think trig is SOHCAHTOA, then you're wildly underestimating trig. Okay, we're cool with that. Oh, thank you for the follow. Very much appreciate it. We're on 448 followers, 2 away from 450, which which is kind of a good milestone. Yeah, I'm so dead. I can't think today. Right, let's focus. Hamza, I'm going to ban you if you say that again. Right, I've got these 3 questions here, but before I look at these, I want to try this one here, because if you look at this, z to the 4 minus mi, it's almost the same as this, z to the 4 plus 9i. It's so similar, right? So let's look at this question very quickly. Okay, and then we'll go through the 3 questions from the last 3 years. Is that all good? Right. Let's have a look at this. Find all the solutions of the equation. So we're going to say question 1, m. We've got z to the 4 minus mi equals 0. Okay. We've got this here, which means z to the 4, the first thing we do, remember we rearrange this, equals mi. Now, don't be scared. M is just a positive real number. In fact, it tells you in the question. M is just a positive real number. We don't know anything else about it. We're just going to leave it in our answer. So our answer is going to be in terms of M. Just like in the last question, 9 was in our answer. You see 9? We're probably going to end up with M in probably a pretty similar position. Right? Let's have a look. Piece by piece. Convert this to r cis theta. R is going to be, well, we've just got one piece of it, isn't it? So it's just going to be m. Theta is going to be, we've turned positive 90 degrees, it's going to be 90. Wow, Kate. This is crazy, huh? I guess you're welcome. This is what you need. Equals m cis 90. Okay. You want me to draw the diagram? Sir, I'm trying to take some shortcuts here for them. This would be m. mi. There you go. Z to the 4 equals m cis 90 plus 360n. So far so good. Z equals, so this is going to be the 4th root of m cis, and we're going to divide all these bits by 4. We just did this, 22.5 plus 90n. Look how similar this is to what we just did. Right? In fact, I probably don't even need to do it anymore. You could carry on. Yeah, I agree with Mr. Murray. It's a must question in the exam. It's appeared in every single one. It's an easy M. 5 points. Straight away. Look, we're halfway done. Right? Let's do this. N equals 0. Z must be the 4th root of m cis 22.5. Done. N equals 1. Z must be 4th root of m cis 90 plus 22.5, 112.5. Now I know if I add another 90 onto that, it won't work, right? So we have to do n equals minus 1. Z equals 4th root of m cis 22.5 minus 90 minus 67.5, and n equals minus 2. Z equals 4th root of m cis, I'm going to sneeze, We're back. 22.5. What are we doing? Minus 2 times 90, is it? So minus 180. Minus 157. There's our 4 answers. 1, 2, oopsies, not 1. 1, 2, 3, 4. Merit. Done. Ugly sneeze. Thanks for the blessings, team. Look at that. Merit. 1 page of working for Merit. And half the page is just doing stuff. Do you have to draw a diagram then? Nope. Don't have to. Doesn't ask to. Doesn't say to. Don't need to. We've found the 4 solutions. Right? Only reason I showed you the diagram was just for you to see that sort of pattern of shifting by 90 every time. Should we ramp up the difficulty a little bit? Should we look at a previous exam problem? Right? The word for word, taken exactly from a previous exam. Right? We'll come back to this one. This is Mr. Maraji's one. I promise we'll come back, sir. Let's ramp it up. Look at maybe this one here. Okay? It looks so similar. Just a tiny bit uglier. Right? Yeah, listen, I need some hype. I'm real, tired. I don't know why. I think getting up early to do maths and then to teach maths, not so good. Okay, let's go from Marissa Maraji. That's inspired me. Right. Okay. Let's look at this one. We're going to look at the 2018 merit question. Whew. 2018 merit. We've got z to the 3 equals minus k6i. Whew. Oh no, my camera, just when I'm getting hyped, my camera dies. That's so annoying. There you go. Again, Miss Brody's saying, let them do it. Start, guys, start. Work ahead of me. I've had webcam issues. You should be on your way. Right? Okay. There's also, I want to let you guys do this one, because it looks nastier, but it's the same. It's the universe telling you to calm down. Hell no. R, cis, theta. Okay. R equals the square root of all of that squared. Who cares? It's just going to be k to the 6. Theta is going to be very careful, draw the diagram. In this case, it's minus some value here. So this is minus 90. So z to the 3 equals r, which is k to the 6 cis minus 90. Yeah, he's right. Draw the diagram. Because you know what happened? If I look at my notes, when I did this, I made a silly mistake of not drawing the diagram, and I didn't make it a negative 90. And then I followed through and made silly mistakes. And I looked back at the answer and I was like, oh, I'm an idiot. Right? So draw that diagram just to quickly do that. Yeah, an absolute numpty. Absolute numpty. That's what people used to say at my high school. I used to get called a numpty by my teachers all the time. Right, you guys with me? Third root of this. Ooh. I'm gonna let you tell me what the number in front of cis is. Okay? What a wally. Number in front of cis, please. What is the value of k? And I can do this last part. That's not too bad. 90 divided by 4. No, wait, divided by 3. Well, that's minus 30. That's not too hard. And that's 120. Yeah, k squared. Good. Right? because we're timesing it by 1/3 basically, right? We're timesing 6 by 1/3. Good. Hey, Pine Boy's not trash, man. They used to call us wombats all the time too. You wombat. You wombat. Right. Z. Oh, let's go. We're almost there. Look, we're almost, like, I'm not even paying attention. We've almost got the question. Remember, I'm going to use a little life hack. Z to the 3. That means my n, my first n, is going to be -1, and then it's going to be 0, and then it's going to be 1. We know that. Okay, squared cis -30 minus 120 is going to be -150. N equals 0, Z equals, this is our nice easy one, cis -30, and our other one, k squared cis, we've got -90 plus 120, oh, too much maths in my head, -90 plus 120, 30, and we're done. 1, 2, and 3. Oh, -30. I told you, silly mistakes today. 90. Thank you for spotting it. Good, 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 good. And there we go, merit, done. If I was sitting calculus paper in 2018, I would have done better than when I said it when I actually did in whatever year it was. Tina can't believe it's a merit, right? Though Shock Side's got a big brain, so does Fat Pikachu. We're happy, right? So the step from merit to excellence is actually huge, I think. Miss Maraji, thoughts? I think the step from merit to excellence is pretty big. Yeah, I wish I said it last year. I would have done so much better than when I said it. I'm pretty sure I avoided complex numbers, which I deeply, deeply regret. Right? Yeah, so he thinks the step from merit to excellence is huge with this concept, right? But what I want you to do, I need to go get a drink. I might get some sugar, so I'm more hype. Can you do this question here, please? We've done almost identical questions twice on this concept, and it appeared in the 2017 exam. We've done 2 questions that are almost identical to this. We've done one that had 1 over root 2 plus 1 over root 2, and we had one that was a minus here, and that's it. Do this question now. I'll go get a drink, and I'll complete it in a minute. Okay? And then I might set this one for homework, because we're actually working really well. Go, go, go. Right. Give me an answer. I've got my answer. I did it while I was out there. Look. 2 biscuits. And the last bit of chocolate. Yum. Oh yes, I get to ban Hamza. Can you hear that chewing? Okay. I hate chewing noises. They're gross. So, let's look at this question here. I'm going to do the speed version, but you got to stop me if you get confused. There's a couple things you should notice when you see this question. The first thing you should notice is that we've got a situation where A and B are both the same and both real. Sorry, both positive. The same and both positive. And that tells us something special about the angle, right? Oh, look at you guys. You're awesome. You're absolutely fantastic. Let's look at R very quickly. The square root of M. Oh, let's give myself lots of room for this because it takes up a lot of space. R is going to be M over root 2 squared plus M over root 2. I didn't need the other bracket. Squared, which is M over 2 plus M over 2, which is the root of M. Is that right? Wait, did I do something wrong? Oh yeah, I did do something wrong. Good spotting, Tina. M squared. Yeah, you're right. I knew it was meant to be something different. Okay. All my hard work is showing by me being tired of making silly mistakes, right? But it's also showing in how well you guys are doing, right? And how quickly you notice these things. So theta, yeah, lots of you guys did sleep earlier. I know I stayed up way too late. I genuinely did, right? Theta in this case, look, if I draw the diagram very quickly, doesn't really matter what M is. We have this angle. These two sides are the same. This angle has to be 45 degrees. Right? So let's write our z to the 4 equals m cis 45. All good. Honestly, from here, it's so straightforward. Like from here, you should be giggling to yourself, going, "Woohoo! I know I just got a merit." Right? As long as I don't make any silly mistakes. So just don't muck it up and you'll be fine. And the only times I muck it up is because I just do silly things here. Right, so get a good sleep before your exam. Because I didn't sleep. I've slept a little bit, not enough. And now I'm making silly mistakes. So we divide this by 4. 45 by 4. 11.25. Plus 36 by 4 is 90n. N equals 0. Z equals 4th root of m. Cis. Can I just write the 4 answers, or do I have to go through all of this? Because I've got the 4 answers here. Have you guys already done it? Yeah, calculus is by far the best game. The science and whatever category is by far the best on Twitch. N equals 1. Uh, 101 will it be? 101.25. N equals, I can't go anymore, so it needs to be minus 1. 4th root of m cis. Yo! Shot for the bits, dude. Very much appreciate it. No message, no nothing, just straight bits. Minus 1 is going to be 0.75, and n equals minus 2 will give us a z of 4th root m cis minus 168.75. And there we go. 1, 2, 3, 4. Okay, so we've been streaming for a little bit over an hour, right? What I'm going to do, I want you guys to do, this is a good question, this one here, right? I think that's the hardest one we just did, and we did it. Well done, right? Give yourself a merit and 5 points if you got it right. I want you guys for homework, please, to make sure you do this question, a 2016 merit. Right, you can check with the 2016 paper answers to see if you get the correct answer. Right, and it's not that hard. And at the very least, do this question as well. Okay? Those are your 2 for homework. These ones here are pretty tough. Now, it's going to take me at least another 15 minutes to go through one of these. Yo, Bits is going hard, man. Maybe he is sending messages. Let me check. So, do you guys think it's feasible for you to do those 2 questions, please? Is that reasonable? No, no message, just... but not the E1s, that's fine, right? These E1s are tough, they are hard, they're difficult to wrap your head around, but once you... Yeah, exactly what Mr. Murray said, men from the boys stuff, right? The kids from the adults. The engineers from the maths teachers. Dude, this bit, you do need to settle down. Right, Hamza's back. Right, so what I do is, Miss Margie has worked really hard to go through these 3 questions. I'm just going to post the answers to those, and if you could work through that, that would be amazing. Or just have a look at that, and if it looks doable, do it, and if it doesn't, don't worry about it, right? When we get closer to the end of the year with revision and stuff, and once we're feeling really on top of all the merit stuff, that's when I'll make sure that we cover some of the real tough E1s. But the most important one, yo, thanks for the follow, dude, 450 followers, let's go. Well, a bunch of people joined late, yeah. So just to reiterate, I'll write it here, the homework. And you can clip it. Homework. The 2016 mirror. Okay. And I can tell you the answers. Or you can check them, but here are the answers there if you want a quick. Oh, that's all the working. I don't want you to see the working. I just want you to see the answers. I mean, it's honestly not that hard. And then I want you to do the question 2 that is a merit. This one here. And then if you're feeling up to it, look at E working that I'll post on Google Classroom. Okay? Because these are hard. These are genuinely hard. This one involves knowing that there's like a little secret quadratic in here. And they're just like long. Okay? Yeah, there's no point joining this late. He's right. But you guys can rewatch the video and have a look. But you can't ask questions. That's going to be us. So we didn't do any E. I thought we might get up to one of these, but I was a little bit slow. Yeah, I've also posted all the exercises on Delta from the last one. We did Kahoots at the end. No way. Yo, Bits, I really appreciate it, man. I'm gonna head out. Thanks for coming. Thanks for stopping by. Thanks for the bits. Really appreciate it. Hope you learned something. Yeah, Mr. Brady's going to put it on his Google Classroom too. He's going to wait for you guys to try it for a little bit. Okay. Chris Neal. Damn straight. Right. The next stream. So tomorrow I'm going to have a break. Right. Tomorrow I need a break. It's my holidays, for goodness sake. I'll take Wednesday off. Right. Which means Thursday and maybe Friday. But I mean, there was not that many people in here today, which kind of annoys me. Right? Like, it got big towards the end, but it kind of annoyed me and made me not want to do it, even though I'm putting in heaps of effort. Me and Mr. Maraji are working really hard on these. Right? So please promote it and get more people in here. It's like so much more worth it the more people are here. Right? I'll promote it to the other calc teachers too, because what we'll do is on Thursday and Friday, or definitely Thursday, maybe Friday, we'll do locus. Okay? So let me put it here. Thursday, we're going to go through locus. Now, I haven't done locus at all, so I'm going to learn it all tomorrow and teach you all tomorrow. No, not tomorrow, Thursday. Learn it all tomorrow, teach you all the next day. Yeah, I know Hamza's told everyone. I really appreciate it. I didn't even eat my biscuits. I didn't want to make noise. Okay, but I'll put it into all the other teachers' Google Classrooms, or tell them to put it in there. But yeah, if you could come back on Thursday, please. Do I think it changes time? Honestly, I don't want to change the time. The time really suits me. Anytime after this, it gets really hot in this room. You see that? That's the sun coming straight into my room, or to the study. So it gets really hot, and I have to have the door shut for my flatmates, because otherwise they can hear everything. They still can, because I've got the window open. So I'm not changing the time, sorry. Right? At the end of the day, it's your education, not mine. Get here at 11. It's worth it. Okay. Yeah, Hannah says the time's fine. Perfect, I agree. Hey, no worries, Dashoksai. Anytime. Yep. The people that work hard come here on time, which is good. Right. Big brain in the chat. Thank you so much for watching. I'm going to go relax. No more maths for me today. But you have 3 more questions to do. I've already done them all. I've done every question on this piece of paper today. That's why I'm knackered. Right. So tomorrow I'll learn locus and I'll teach you on Thursday. Can I run arms as a leaving gift? I know what you meant to say. but I think doing an arms is funnier. Right? Thanks so much, guys. Um, enjoy yourself. Do those questions, and I'll see you on Thursday. Spread the word. See ya. Wrong one. See ya.